The first equation we have here is y equals 1 plus sine x over 2. Now, using this equation, we can find a variety of things. First is the amplitude. In this particular case, the amplitude is only 1 because there is no number directly in front of sine. So it's simply 1. Now, to find the period, we take 2 pi over b. In this case, b is 1/2. So 2 pi over b results in a period of 4 pi. To find frequency, we take b over 2 pi. So once again, 1/2 over 2 pi, which gives us a frequency of 1/4 pi. The vertical shift is +1 due to this +1 out front. So +1. And in this equation, there is no phase shift. Now we can move to our table. And these are coordinates given to us by the book for the original sine x function. And so due to the frequency and the phase shift, our new x value will be multiplied by 2, and our new y values will have 1 added to them. So the first coordinate would be 0, 1. The second coordinate will be pi 2. The third coordinate will be 2 pi 1. The fourth will be 3 pi 0. And the fifth will be 4 pi 1. So we can use these points as our reference points for the graph. So to start the graph, we first need to label our graph. So due to the phase shift, the graph will actually not go below the x-axis. So it's actually going to start at 1 instead of 0. So this is 1, 2. And so each unit is adding pi. So the first unit is pi. Second unit is 2 pi. 3 pi. 4 pi. And this is going to be 1 full period. Then 5 pi. 6 pi. 7 pi. And 8 pi. And combined, these are 2 full periods. So on a sine equation, it would originally start at origin 0, 0, but due to the vertical shift, it is going to move up 1 to 0, 1. And following the pattern, pi 2, and then 2 pi 1, 3 pi 0, 4 pi 1. So if we connect these, it makes a sine graph. And now we simply follow the same pattern for the second period. So it would be 5 pi 2, 6 pi 1, 7 pi 0, and 8 pi 1. And that is this equation graphed.
Is the function y equals -1/2 tangent 2x. And from this equation we can extrapolate that the amplitude is 1/2 because you take the absolute value of a, which is -1/2. And the period is 2 pi over b. b is 2, so 2 pi divided by 2 is pi. And the frequency is just the reciprocal of the period, so that's 1 over pi. And we have no phase shift or vertical shift in this graph. So in the parent graph of y equals tangent x, the vertical asymptote is negative pi over 2. But due to the transformations that we have here for our graph, the vertical asymptote is going to be negative pi over 4. For the intermediate point of the parent graph, it's negative pi over 4, negative 1. For our intermediate point, we have negative pi over 8 and positive 1/2. For our x-intercept, we still have 0, 0 for our graph, and for the interlude point, we have pi over 8 and negative 1/2. And the next vertical asymptote is pi over 4. We have our asymptotes at pi over 4 and at negative pi over 4. And then if we repeat them every pi because the period is pi. Our next asymptote would be at 9 pi over 4. And that graph continues. Next, we can graph our intermediate point at negative pi over 8, negative 1/2, our x-intercept at 0, 0, and our interlude point at pi over 8, positive 1/2. And then when we connect these, graph looks something like this. And then our next intermediate point would be at pi, negative 1/2. And then our next x-intercept would be at 5 pi over 4 and 0. And then the interlude point would be 2 pi, positive 1/2. And that is our second period of this graph.
And this is our third equation. Y equals secant x plus pi over 2. Now, using that equation, we are going to once again find the period, which in this case is 2 pi because b is 1 and the defined period is 2 pi over 1. So period is 2 pi. The phase shift in this equation is going to be negative pi over 2 because to find the phase shift you take negative c over b. So in this case it is be negative 2 pi over 1, which is negative pi over 2. So phase shift is negative pi over 2. Now, once again, our coordinates on our graph are going to be affected because the x is, all x values are going to have pi over 2 subtracted from them. However, y values are going to remain the same. So, this is our first, according to the original function, our first vertical asymptote would be at x equals negative pi over 2. But with our new equation, our first vertical asymptote is going to be at x equals negative pi. Then our new maximum is going to be negative pi over 2, 1. Our new vertical asymptote is going to be x equals 0. Our new minimum is going to be pi over 2, negative 1. And our new vertical asymptote is going to be x equals pi. So now we are going to graph, and we first have to draw our vertical asymptotes. So we have a vertical asymptote at pi, vertical asymptote at 2 pi, and a vertical asymptote at negative pi, and negative 2 pi. So our first maximum is at negative pi over 2, 1. So we define that, and that is right here. So negative pi over 2, 1. And then our first minimum would be at negative 3 pi over 2, negative 1. So we would graph that. And that is one full period. Now our next minimum is at pi over 2, negative 1. So down here. And our next maximum is at 3 pi over 2, 1. And the graph, the units in the graph go by every pi over 2. So pi over 2 pi, 3 pi over 2, etc. And that is that equation solved and graphed.